Hello, this is Dr. Bailey. In this video, we'll be addressing two learning objectives. By the end of this video, I want you to be able to convert between mass and the number of whatever it is we're looking at. And so the different units for that, we're going from grams or AMU to the number of atoms, the number of molecules, or the number of moles. And then the second component is to be able to calculate the molar mass of a molecule or a compound. So let's get started. First thing we're going to do is ask this question. So I want you to pause the video, read the question, and go ahead and decide which answer you have and why. When you're done, unpause. So for this question, what we're being asked to do is thinking about if we have a certain amount of mass of magnesium, that means that there's a certain number of atoms that are present, and we can convert back and forth between those using a molar mass or an atomic mass. Question is gold heavier or lighter than magnesium? So what that requires us to do is to go look at our periodic table, and what we can see is that magnesium is element 12 on the periodic table, and gold is element 79. What we can see from that is that gold is going to be much heavier, an average atomic mass of 196.97 grams per mole, and magnesium is 24.305. So the question is basically asking, if we have, let's say, 100 magnesiums and 100 gold, which is going to be heavier? Hopefully we can start thinking about, well, gold is much heavier per atom, so if we have the same number of them, gold is going to be much heavier for the same number of atoms as magnesium. It's like asking if we have 1,000 shoes versus 1,000 cars, which is going to be heavier. So that means that a sample of gold containing the same number of atoms is going to weigh significantly more than 34.5 grams because it has the same number of atoms as magnesium. So let's actually do the calculations, which is our next question. That amount of magnesium, how many atoms of magnesium are in the sample? Go ahead and pause the video again, and then you can go ahead and resume once you're ready to do these calculations. For this question, we need to set this up as dimensional analysis because you are in my class, or if you are in my class, this is how we do it. If you're not, then there may be other ways you've been taught, but I'll show you why dimensional analysis is so important here. So the first thing we're going to do is identify the starting quantity. Our starting quantity is 34.5 grams of magnesium. We're going to put that over 1. And then we're going to think about what different conversion factors we have available in order to convert from grams to the number of atoms. And I'm actually going to say that we have two different approaches for this. So we're going to put the second approach here, and we're going to talk about which one I want you to use and why. So if we go ahead and look at the first way of doing this, we have to figure out how to get from grams to atoms, and specifically for magnesium. And so I said earlier that we know that magnesium, if we have 1 mole of magnesium, that weighs 24.305 grams of magnesium. This is known as the molar mass, and the reason it's called a molar mass is it's 1 mole, it's the mass of that 1 mole for a particular element. So molar mass is an easy term to remember once you have the conversion factor already written out. So then the next thing we're going to think about is, okay, this conversion factor allowed us to go from grams of magnesium, how much it weighs, to how many of them there are in the unit of mole. The next thing we want to do is, if we know how many there are in moles, we can convert from how many in moles to how many in individual things, or atoms in this case, because we know that 1 mole is always equal to 6.022 times 10 to the 23rd of those things. So in this case, this magnesium atoms are those things that we're interested in. So we want to go back through and make sure that we use the right, or the appropriate conversion factors. The first conversion factor we used allowed us to convert from grams of magnesium to moles, and this is moles. We could probably put magnesium there, although this next conversion factor holds true for anything. And then we used the molar conversion factor to go from moles to atoms by Avogadro's number. And then the final unit that we have is magnesium atoms. And so then we can go ahead and do our calculations, if I have a calculator handy, which I do. And we're going to do 34.5 grams divided by 24.305. And then we're going to multiply that by Avogadro's number. And I come out with 8.55 times 10 to the 23rd. The unit is really important, atoms of magnesium. So we want to check to make sure that that made sense. We know that if we have 24.305 grams of magnesium, that's a mole of them, which would be 6.022 times 10 to the 23rd. We have just more than 24 grams. We have 34, which is, I don't know, 50% more. So then our answer on the far right should be similar magnitude or size to Avogadro's number, but slightly more, maybe about 50% more. And so that looks like that holds true. We have just more than an Avogadro's number of atoms because we have just more than 24.305 grams of that substance. So let's look at the second approach, which is one that if you're using certain homework platforms, they don't necessarily support. The first thing that we could have done is convert from grams of magnesium to the weight in AMU. Because we know that 1 gram of anything is the same as 1.6606 times 10 to the negative 24th AMU of that thing. This is converting from weight to weight. Instead of what we did above here is we converted from weight to number. The second one I just wrote here is converting from weight in one unit to weight in another unit. While both of these are appropriate to use and completely correct mathematically and will give you the same answer, most homework platforms will want you to use molar mass first, converting to moles, and then converting to atoms. If we complete the rest of this problem, now we have the mass in AMU, and we know that the molar mass can also be used as the atomic mass. So we know that if we have 1 atom of magnesium, that weighs 24.305 AMU. So if we went through and did these calculations, you will find that you get the exact same answer. And in part, that's because the two numbers that I just circled are reciprocal of each other, related through Avogadro's number. But the important part to keep in mind is your homework on a lot of platforms is going to want you to convert from grams to moles first. That's this approach on top, instead of converting from grams to AMU and then AMU to atoms. So let's go ahead and answer both of these questions and then resume the video when you're ready. So in your class, you might not yet have worked with the unit of molar mass for more than one element. So we just did one for magnesium, we talked about gold, but here we have a molecule. And so this molecule, if we think about it, it has 1 oxygen and 2 hydrogens. So that little subscript 2 means that within the one molecule, we have 2 hydrogens attached to 1 oxygen, and they're all interacting with each other. And so for this part, we're going to say, well, how much does this water molecule weigh? We know that it has 1 oxygen, and it has 2 hydrogens, so that means that we're going to add up 15.999 for the mass of 1 oxygen, and then we're going to add 1.0079. We're going to have to do 2 of those because there's the mass of hydrogen as well. And so when we add together those numbers, if we're being very accurate, we are going to get 18.0148. That is the molar mass of water. So the second part is, what are the units? Go ahead and make sure you answer that before you listen to my description. So there's two different ways that we can look at the answer to this. The answer is either AMU per one molecule. So this is how many AMU one water molecule weighs, but it also is 148 grams is the molar mass. And so this question specifically asked about the molar mass. So the molar mass would be, we would use units of grams per mole. So if we have 18.0148 grams of water, we know that we have 1 mole of water molecules. Let's go ahead and try the next one. This one's a little bit more complicated. If you're not familiar with salts, go ahead and pause and calculate the molar mass of this compound, and then we'll talk through it. In order to determine the molar mass of a salt, we have to think about what all these subscripts mean. Subscripts are just the number that are below the individual element. If a number exists out front here, we call that the coefficient, and that represents how many of all of these things there are. In this case, there's only one of them, but you might see something where you have 3 of everything there, and you basically think about it as parentheses around the whole thing. But what we're focusing on is the subscripts. Sub because they're scripts below. Sub, think about like submarine. And that means that in this one compound, we have 3 magnesiums, we have 2 of everything in the parenthesis, which is called a phosphate, and that phosphate, each phosphate, has 4 oxygens. So we're going to need to do some math now. We're going to think about, okay, how much each one of these weigh. So we're going to do a little table here to help us. We're going to have the number of each of them, what the element is, and then we're going to have the weight. So the first one, so we have 3 magnesiums, and we said in that last one, that magnesium, each magnesium weighs 24.305. We're going to have either AMU, if we're talking about molecule, individual atoms, or we're going to talk about moles if we're talking about how many grams there are. So then we have, go ahead and think about, pause it and think about how many phosphoruses there are, P's, and how many oxygens, O's, there are in this compound. Because we have a 2 outside and only 1 phosphorus inside, that means we have 2 phosphoruses. Phosphorus weighs 30.974, according to the periodic table I have. And the oxygens, we have 4 for every 1 phosphate, but we have 2 phosphates. So that means that we have a total of 8 oxygens, each weighing 15.999. So now what we need to do is add them all together. So we have 3 times 24.305 plus 2 phosphates at 30.974, and we have 8 oxygens that weigh 15.999. So I'm going to go ahead and add those up. Make sure you're doing the same and doing your calculations on your own to make sure that you come up with the same numbers that I do, to make sure you're using your calculator appropriately. And I come up with 431. That sounds really high. Let me recheck that to make sure that I did this appropriately. It looks like I added a zero. And as I check my calculation, it looks like I made an error, and the number that I come up with is 262.855. If we're going back and we're deciding what units we have, it's the molar mass. So molar is the unit of how many, mass is how much it weighs, so we're going to do grams per 1 mole. And this is a conversion factor now we can use in order to convert from grams to number of them, and vice versa. I hope you found this video useful in determining how to find the molar mass of a molecule or a compound, and then how we can use those numbers to convert from grams to moles.